Good afternoon, students. Today we will discuss the transmissibility and isolation. Transmissibility is the measure of the effectiveness of the vibration isolating material. It is of two kinds: force transmissibility and motion transmissibility. The motion transmissibility is same as that of x and y derivation, which was discussed in last class. Force transmissibility. It is defined as the ratio of force transmitted to the force applied on the system. That is, it is the ratio of Ft to the F0, and this is also known as isolating factor. So this is the system in which a spring and damper is mounted on the body of M, which is excited by a force F0 sin omega t. So the force polygon for the system will be as shown in figure. The force transmitted will depend on the spring and damper. How much force is absorbed by spring and damper will be absorbed, and rest will be transmitted to the rigid section or rod or anything on which this system is lying on. Therefore, force transmitted is the vector sum of spring force and damping force. In next slide we will see this force transmitted is a vector sum of spring force kx and damping force. Therefore, Ft at alpha angle is a summation of kx square plus cx omega square and whole under root of this factor. Similarly, force transmitted, this is force transmitted, and force impressed F0. It is same as that of the in other derivations. It is a vector sum of spring force minus inertia force and damping force. Therefore, the F0 can be written as c omega x square plus kx minus mx omega square, the total whole square. Therefore, F0 is integration of it is a square root of these two factors. Therefore, transmissibility ratio Tr, epsilon, or anything that we call it is transmissibility ratio. It is Ft, that is vector sum of spring force and damping force, and F0, it is under root of kx minus mx omega square total term square plus c omega x ka square. Therefore, we are dividing both numerator by k. So the transmissibility ratio can be written as square root of 1 plus 2 zeta omega by omega n ka square divided by under the root 1 minus omega by omega n ka square का total का square plus 2 zeta omega by omega n का square. We want this transmissibility ratio less than 1. So we want this ratio to be less than 1. To making this ratio low, we need some conditions are there by which we can get this condition. By raising this system frequency, angular velocity omega of the system should be very high than natural frequency or natural velocity. So conditions are: increase the value of omega to decrease the value of omega n. For decreasing this value of omega n, it is the under root of k by m. Since it is the under root of k by m, so by lowering the stiffness or highering the value of m, we can get low value of natural frequency or natural angular velocity. The curve for transmissibility ratio and frequency ratio is shown in this picture. So we can see that root 2 is one condition. The omega by omega n root 2 at this point. It is merging and the transmissibility ratio is 1. A transmissibility ratio 1 and this value root 2. Above this root 2, these all the values are transmissibility ratio is lower than 1, and above here up to root 2 it is above 1. So for transmissibility ratio to be reduced, or this section is also known as isolation section. So to improve isolation, we need omega that is more than root 2 omega n. The salient features of this diagram are transmissibility is 1. This transmissibility omega by omega x by y or TR is 1 when omega by omega n is 0 or close to 1 in this condition, or omega by omega n is small up to root 2. For undamped system when zeta equals to 0, this is zeta equals to 0, 0.5, 0.1, 0.2, 0.25, 0.5 and 0.1. So zeta it is almost infinite. So transmissibility infinite for this condition, omega equals to omega n resonance condition, and zeta equals to 0. For all damping greater than transmissibility less than 1, this section, and omega by omega n greater than omega root 2, this section. Here transmissibility is less than 1, here it is more than 1. And fixed base system, in which there is washing machine, there is no any spring or damper is there, and in generator on the base there is also not any spring or damper is provided at the base. So rubber cork etc. are required to isolate the system from the base. In spring coils are used no base isolation and with base. In this spring coil can be used as isolation material. It will provide us more stability. Isolation condition, as we have already discussed about it, more than root 2 value of omega by omega n will give us more isolation, and this region higher mass is required to reduce the omega n.